This video will cover the 2019 HSC Mathematics Extension 1 past paper for the question 11 in session 2. And here within the question 11, here is the first question for A. Find the acute angle between the lines of x minus 2y plus 1 equal to 0 and the other line is y equal to 3x minus 4. And to solve this question, we need this formula. Tan theta is the acute angle formed by two lines. So tan theta equal to the absolute value of m1 minus m2 divided by 1 plus m1 and m2. So we have to find two gradients of these two lines. Okay? So we need to convert this one a little bit. It would be 2y equal to x plus 1. So divided by that 2 on both sides, we have y equal to half x plus half. Okay, so we have the gradient for this one, m1 equal to half. And the gradient for this one is 3. So we have m2 equal to 3. Then we can sub in these two gradients into this formula. Because we have an absolute value, so it doesn't matter which one is m1, which one is m2. We just sub it in. So we have tan theta equal to the absolute value of half minus 3 divided by 1 plus half times 3. Okay, so that equal to so negative half over 2 divided by 5 over 2. So negative 5 over 2 divided by 5 over 2. So here's negative 1. After the absolute value is 1, which means this acute angle should be 45 degrees. Okay? And go to question B. Oh, on the side, by the way. This question is not in the 2020 syllabus. Okay, this question is not in the syllabus of this year. Then go to question B. The question is, for what values of x is x over x plus 1 less than 2? I'll introduce you two methods to do this question. Okay, the first method is to separate the question into two situations when x plus 1 greater than 0. The other one is x plus 1 less than 0. So the first situation is when x plus 1 greater than 0, which means x had to be greater than negative 1. And because this is positive, we can times x plus 1 on the both sides to have x less than 2x plus 1. Okay, so we have x less than 2x plus 2, so negative x less than 2, so we have x should be greater than negative 2. Here's the result, but here is the condition. We should compare the result with the condition. The condition is x had to be greater than negative 1, but the result is x is greater than negative 2. So compare with the condition, the overall result for here, we have to choose x greater than negative 1. Okay, this one. And the second situation is when x plus 1 less than 0. So when we times a negative number on the both sides, we have to change the sign to the opposite to become x. Oh, sorry. Great. This one is x less than negative 1. So times x plus 1 on both sides, you have x greater than 2x plus 1. Okay, so the result for this one is x is less than negative 2. So compared to the condition x less than negative 2, the result is covering all the conditions. So for here, x less than negative 2 is the answer. So here's the first answer, here's the second answer. So that the final answer should be x greater than negative 1 or x less than negative 2. Okay, and the second method is we can times a positive number on the both sides to keep this sign. So we can times x plus 1 square on the both sides because x plus 1 square is positive. So we don't need to change the sign. So we have x with x plus 1 times x plus 1 squared less than 2x plus 1 squared. Okay, so x plus 1, we cross out 1. So on the left hand side we have x plus 1 less than, we expand this one to have 2x squared plus 4x plus 2. Okay, so we have 2x plus 2 less than 2x squared plus 4x plus 2, and then 2x squared, so here is x squared plus x. Okay, compare these two, we have, bring this one to the other side, we have x squared, this x to here, we have 3x, and then we keep the 2, it's greater than 0. Okay, this 1, 3, 2, we using the cross method, 1, 1, 2, 1. So these 2 times together is 2, 1, 2 is 2, 1 times 1 is 1, so we have 2 plus 1 is 3. Okay, so that we have 1 plus, so we have x plus 2 times x plus 1 greater than 0. Okay, okay, we find two zeros from here, negative 2 and negative 1. So negative 2, negative 1. And because the coefficient of x squared is positive, so the parabola should look like this. And we need greater than 0 only, so we are choosing these two parts. So for here, the x has to be less than negative 2. For this part, the x has to be greater than negative 1. So we have two answers, is x less than negative 2 or x is greater than negative 1. Negative 1. So we should have the same answer, either this method or this method. And don't to make square on the both sides. Okay, this we can't. If we square it on the both sides, which means we eliminate one situation, which means here could be negative. Yes. Okay, in question C, the question is the line segment AB. So here's the AB. Is the diameter of the circle, center at O. So here's the center. AB is the diameter. The line CD is the tangent to the circle. So CD is the tangent to the circle at C. And BD is perpendicular to CD. So BD is perpendicular to CD. So this angle is 90 degrees, okay? As shown in the diagram. So we need to prove the angle ABC equal to the angle CBD. So the angle ABC. So we need to prove this angle equal to CBD. This angle. Okay. In this question, we need two theorems: the angles in semicircle and alternate Simon theorem. So for angle in the semicircle, to put angle ACB is a right angle. Okay, and for alternate Simon theorem, the tangent cutting at the circle with a chord over here, this angle. I'm using different colors. This angle equal to this angle. Okay, that's why we have. So from the angle in semicircle, we have the angle ACB equal to 90 degrees. And also because BD is perpendicular to CD, so which means this angle is also 90 degrees. So we equal to the angle CDB. And from the alternate stiffness theorem, we have this angle equal to this angle. The angle CAB, this angle equal to DCB, equal to angle DCB. So in this triangle and this triangle, we have two pairs angle are the same. So this one equals to this one. This angle is equal to this angle. So within this triangle, angle ABC equals to 180 minus this angle and this angle, which means the angle ABC equal to 90 degrees minus the angle CAB, and also the angle of CBD equal to 90 degrees minus DCB, angle DCB, because angle CAB equals DCB, which means we are 90 degrees minus the same thing. That's why we have the angle ABC equal to the angle CBD. Then we have angle ABC equal to the angle CBD. Okay. Yeah, but this question is not in the 2020 syllabus as well. So hopefully you won't see this question in your exam. Okay. Okay, next one. D. Find the polynomial of the QX that satisfy these equations. Okay, we need to find this QX from this equation. Okay, and I will bring these three into the left hand side to combine with this 7 to make it easier. X cubed plus 2x squared minus 3x. So bring these 3 to become negative 3. Negative 7, negative 3, we got negative 10 equal to x minus 2 times qx. Okay, so qx equal to the left hand side divided by the x minus 2. Okay, we have x cubed plus 2x squared minus 3x minus 10 divided by x minus 2. Okay, so x cubed, we need to times x squared to make x cubed. So we have x times x squared, we have x cubed. Negative 2 times x squared, we have negative 2x squared. Okay, next that. This line minus this line is 0. This one we have 4x squared. Okay, positive 2x squared minus negative 2x squared, we got positive 4x squared. And then we bring these 2 down over here. Okay, compare the x to 4x squared. So we need to times 4x to become 4x squared. So x times 4x, so we have 4x squared. Negative 2 times 4x to become negative 8x. Okay. This one, negative 3x minus negative 8x to become 5x, positive 5x, and bring this negative 10 down. Then we have times 5. So 5x, we have 5x. So negative 2 times 5, we have negative 10. Done. Okay, so this part is the QX. So we have the Q. Okay, so we have the QX equal to x squared plus 4x plus 5. Okay, that is your final answer. Yeah. Okay, call for question E. To find the integration of 2 sine square of 2x, and because we can't do that integration directly for the sine square, because that will involve a chain rule inside. So the best way is try to reduce the power based on this equation. So we have cos 2 alpha equal to alpha square minus sine alpha square, which means we change this one into 1 minus sine alpha square. We have 1 minus 2 sine alpha square. So we have 2 sine square compared to this one. It's almost the same. So we have 2 sine alpha square equal to 1 minus cos 2 alpha. Right? Okay, convert this to this one, 4x. Okay, we let alpha equal to 4x. Okay, summing 4x into here, we have 2 sine 4x squared equal to 1 minus cos 2 times 4x, we have 8x. Right? So then we have reduced the power from 2 to only 1 power. Then for cos 8x, we can do the integration directly. So we can change this one into this one. So we have 2 sine 4x squared dx equal to integration of 1 minus cos 8x dx. Then we can do the integration directly. With an x, we have, for this one, we have x minus, because here's 8x, from the chain rule, we have to keep 1 over a to keep this one into, coefficient number is 1. So for cos, we have sine 8x, okay, and then plus c, and don't forget this c, okay, without this c, just incorrect. So the final answer is x minus 1 on 8 sine 8x plus c. Okay. For question F, next one. Okay, F. The price winning symbols are printed on 5% of ice cream sticks. So only 5% of the all ice cream sticks have these winning symbols. The ice creams are randomly packed into box of 8. So with one box, there are 8 ice cream sticks. So one ice cream stick has 0.05 probability to get a winning symbol. So the question is, question 1, what is the probability for one box contains no price winning symbols, which means all the ice creams in one box have no symbols at all. So the unsuccessful for the probability is 0.95, which means the probability of one ice cream stick not getting any price winning symbols. For none of them, which means probability of no price winning symbol. So we have 8 ice cream sticks. They're both unsuccessful. So that's the answer. So it's roughly equal to 0.663. Good? Yep. Okay. The second one. What's the probability that a box contains at least 2 pricing winning symbols? So to handling a question of at least 2. So for example, we have one box. So here is 2, here is 6. So at least 6. So there are totally 9, totally 9 possible outcomes. So here will be 0, no winning symbols at all, and only one symbol winning symbols. And here okay, for the second one, what's the probability that a box contains at least 2 plus winning symbols? So we have at least 2. So we need 2 or 3 or 4, 5, 6, 7, 8, or all of them have winning symbols, at least 2. And the opposite is could be 0, no winning symbols at all, or only one winning symbols. And to handle at least question, we can using the total to subtract these two situations to getting these two, because the total is 1. So we can have the probability of at least two winning symbols is 1 minus the probability of not getting any winning symbols, and minus the probability of getting one winning symbols only, which means here is 1 subtract this 2, subtract this part, then we can get this part. Then can satisfy that. And the question is at least 2 winning symbols. So here is 1 minus P0 equal to this one. Okay, 0.663 minus P1 is 8, C1, and 0.05 to the power of 1 times 0.95 to the power of 7. And use your calculator to calculate 8C1, and then times this one, and then your final answer should be around 0.057. So which means the probability of at least getting 2 winning symbols is 5.7%. Yes, 5.7%. Or you can say this one as 5.7%. Okay? Yeah, that will be all for the question 11. And I'll see you in next video for question 12. If you like my video, please give me a like and subscribe my video. See you in next video. Thank you.